right, hi everyone. So I am going to be out for the rest of this week because my son is quarantined, my 2-year-old. Hit the daycare, there was a positive case at the daycare, so he's quarantined until the 25th. So I'm going to be out the rest of this week, but we're still going to continue things like normal because we have a test coming up, we have an exam coming up, and I don't want you guys to miss out on anything that we were supposed to cover. So we're just going to still continue with what I was planning to do. It's just going to look a little bit different, right? So you're just going to really have to be responsible for making sure that you're doing what you're supposed to be doing, making sure you email me if you have any questions. I'll be checking my emails nonstop and replying and trying to help you guys out as much as I possibly can, okay? So I'm going to do today's lesson as a video, just like I did. This is usually what I do whenever I have to have a sub, so I just figured this would be the easiest way to do this. So you guys should have this notes packet. This is what I left with the sub to pass out. So it is notes 6.4. We're going to be talking about triangle mid segments today. It's going to be a pretty short lesson because the rest of today's class, I wanted to give you guys time to work on the study guide because we do have a test coming up. So the next time that you're in this class, you will be taking the test for chapter 6. So the first part of today, we're just going to wrap up chapter 6, the last part that we have to learn. And then the second part of class, you're going to be reviewing for the test, okay? So we're going to talk about something called mid-segments today. So a triangle mid-segment. And a mid-segment, it's kind of what it sounds like. It's a segment that's in the middle. So a triangle mid-segment, if you look at like this outer triangle here, you'll notice it has like a line going through it, this line right here. That line is the mid-segment. So this from D to E, that's called the mid-segment. And it's created by connecting the midpoints. That's why it's called mid-segment. So it's connecting the midpoints. So if you just connect this midpoint to this midpoint, boom, that is a mid-segment. So we'll say that DE is the mid-segment. And there's some special relationships that happen with mid-segments, and that's most of what we're going to be talking about today. So the mid-segment is going to be parallel to that third side. So if you look up here, you can kind of see that like this line and this line, those are parallel lines. You can tell kind of by looking at them, right? And that's always going to be true for mid-segments. So the mid-segment is always going to be parallel to that side that's across from it. So that's one thing that happens. And the other thing that happens is it's going to be half as long as that third side. And we'll do some examples of that in a bit, but the mid-segment is going to be half of that side across from it. So using the diagram above, so like using this picture right here, we're just going to label a couple things. We will say that AC is parallel to DE. So that's one relationship that happens. And then we can also say that DE, which is the mid-segment, that's going to be half of AC. You can also think of it the other way around, right? Like if you think of it as AC is going to be equal to 2 times DE. That would be the other way around, right? Like this side is going to be twice as much as this side. And there's actually 3 mid-segments in a triangle, in any triangle, because you can connect the midpoints of any of the sides, right? So like if you connect those 2 midpoints, you've got a mid-segment there. If you connect these 2 midpoints, you've got another mid-segment there. And then if you connect these 2, you got another mid-segment there. So you can draw 3 mid-segments of any triangle, and they all connect, and they create this little triangle on the inside. And that's called the mid-segment triangle. And we honestly don't do a whole lot with it, but that's what it's called. It's called the mid-segment triangle when you connect all those. Okay, so let's just do some very basic examples to start off with. So looking at these triangles here, they are telling you that DE is a mid-segment in all 3 triangles. So this line is a mid-segment, and that means a couple different things, right? So that means that this is a midpoint, right? That means this is equal to this, and this is equal to this, because it's like kind of like a bisector, right? It also means that the mid-segment is half of whatever that is. So if we wanted to figure it out, we could just take half of 28, right? Or basically 28 divided by 2. So x in this case would equal 14. In the next example, it's the other way around, right? They're giving you the mid-segment and they are asking for the length of the side here. So we would just have to double the mid-segment. So 15 times 2. So x would equal 30. And then in that last example, they're not asking for the mid-segment or the side this time. They're asking for this other piece. Now, because this is a mid-segment, that means those are midpoints, which means that this has to be equal to this. So x would just be equal to 9 because those have to equal the same thing. Okay, so those are just some basic examples. Now let's look at a few more that will ask us for information. All right, in these first two examples here, they're just asking us to identify the parallel segments, and they kind of connected all these mid-segments here. You have 3 different ones. So if you look at this one here, that mid-segment is going to be parallel to this side. So we can label that one first. We'll say XY is parallel to QS. So that's one of them. And then we can do that same thing for the rest of them. So here's another mid-segment. I'm just going to use blue for this one. That's going to be parallel to this side. So it's always going to be parallel to the side that is like across from it, right? So those are parallel. We can say XW is parallel to RS. And then finally we have this one here. So WY is going to be parallel to QR. Okay, the next one is the same thing, right? So these are pretty simple. You're just kind of matching them up. So here I'm going to start with JK. JK is going to be parallel to FH. And JL, that one's going to be parallel to GH. And then finally, KL is parallel to GF. Okay, so now they're going to give us some with numbers, and we're going to have to find some of these missing pieces here. So let's take a look at number 3. It says that L, M, and N are midpoints of the sides. So that means that all of these little segments here, those are all mid segments because they're telling you that these points here, those points are the midpoints. So let's label the rest of this information that they give us. So PR is 46. That's from here to here. And then they tell us that PQ is 40. So this is 40. And LN is 17. So that's this right here. And then they're asking for all of this missing information. So let's take a look. First, they want to know LM. So LM is this segment right here. So if you kind of match that up with the side that it goes with. So LM is the mid segment, and it's parallel to this side at the bottom. So remember, the relationship here is that this piece is always going to be half as much as this piece. So we can just take 46 and divide it by 2. And that would give us what LM is supposed to be equal to. So that would be 23. All right, so that is LM. And now let's take a look at the next one. So the next one says MN. So if I look at MN, that's this mid-segment here. And we're going to use that same relationship. This mid-segment is parallel to this side of the triangle, which is equal to 40. So if I take half of 40, that should be my mid-segment, right? Half of 40 is 20. So MN would be 20. All right, and then QR. So QR goes from here to here. And this one is a little different. So this time they're asking for the side of the triangle. So, and we can't really figure it out. Based on these other sides, we can't use those to figure it out. So we're going to have to use the mid segment to figure it out. So this mid segment is 17. And remember, this is always half. So if I want to figure out the side, I would just double it. So 17 times 2. So that would give us 34. All right, and then the last piece that they want is MR. So let's go ahead and figure that out. MR is this piece right here. Now remember, we just figured out that QR is 34, and because this is a midpoint, that means each of these pieces would be 17, because half of 34 is 17. So that's what MR would have to be. Okay, so let's take a look at this next one here. So once again, they're telling us that F, G, and H, these are all midpoints, right? Which means these segments in the middle of the triangle, those are the mid segments. So let's label the information they give us. FG is equal to 9, so that would be this mid segment here. GH is equal to 7, and CD is 24. That's this whole side here, 24. Okay, so let's try to figure out the missing pieces here. So the first thing they're asking for is CE, which is this side of the triangle. So you wanna try to find a mid segment that's parallel to that. That would be this one. And if you take 7 and double it, that would equal the side, right? So 7 times 2 is 14. So that one's all done. And let's take a look now. Oops, I didn't want to erase that. Let's take a look now at the next one that they want. So the next one they want is DE. That's this side. So I want to try to find the mid segment that's parallel to that, and that would be this one here. So we're going to take 9 and we're going to double it, right? Because the mid segment's always half of whatever this is. So we'll do 9 times 2, which is 18. All right. So that's, oops, this is 9, this is 7. Okay, so FH. FH is this mid segment here, and this time we would have to use the fact that the whole side is 24. So we're going to take half of 24. So that would be 12. And now they want the perimeter. So remember, perimeter means to add up all the outsides. So we kind of want to make sure we have all the outsides, right? We know that one side is 24. We just need these other two sides. We do know that this side, DE, we found it already, right? We said it was 18. And we found CE already also. That was just 14. So they want the perimeter of CDE, which is this outer triangle here, CDE. So you would just have to add all those up. 24 plus 18 plus 14. And that would give us 56. Okay, so let's take a look at some problems that involve a little bit of algebra. So number 5 says find DE. So let's take a look at what we have here. So they're giving us, this is a mid-segment. I know it's a mid-segment because of the way they marked the picture, right? This is a midpoint because these two are congruent. This is a midpoint because these two are congruent. So I know that this is a mid-segment. And the way that you would set this up, so remember the relationship. We know that this one is always half of whatever that is. Or an easier way to think of it would be to think of the bigger one. Think of this as 2 times the smaller one, right? Like 2 times the smaller one. If you wanted to make an equation that said that, we could say, okay, 2 times the smaller one, which is 4x plus 1, has to equal the bigger one. So we'll put 11x minus 25. This is how I would normally set these up. I would do 2 times the mid-segment equals that bigger side. And then once you have this equation here, you can just solve this. And we'll have to distribute in order to solve this, right? So this would become 8x plus 2 equals 11x minus 25. And then you can rearrange this however you normally would. Once you move the 8x over here and the 25 over here, you're going to end up with 3x equals 27. And then you can divide by 3 and you'll get x equals 9. But that's not what they want, right? They want DE. So you're just going to have to plug it in. DE is right here. You're just going to have to plug it into that 4x plus 1. So 4 times 9 plus 1. That's going to give us 37. So that would be our final answer. DE is 37. All right, let's take a look at number 6. so number 6 is asking for a lot of different angles here. So we haven't really done anything with angles yet with these problems. So let's try to figure out how we're going to do this. Okay, and the way that I like to do these problems, typically these problems that are asking for like a lot of information, I don't always find them in the order that they're asking for it, if that makes sense. Like you don't have to start with angle 1 if you don't want to. What I like to do is just look at the picture, and I like to just try to fill in the picture. It's kind of like filling in a puzzle, right? Like we've done a lot of problems like this where it's kind of like figuring out pieces to a puzzle. So let's just start with what we have and see what we can do here. One thing that I notice right away is that these two angles are right next to each other on a straight line. And remember, we learned about what that is a long time ago. Straight lines always equal 180. So if I wanted to figure out angle 2, I could just do 180 minus 127, and that would give me the measure of angle 2, which is 53. So I know that angle 2 is 53. I'm going to go ahead and label that on my picture here. So angle 2 is 53. Okay, so let's see what else we can do. So usually when you have mid-segments, this is a mid-segment, you're going to have to use parallel line relationships, which we haven't done these in a long time, but we do know that those lines are parallel. And you have a couple transversals here. So again, I know we haven't talked about these in a while, but if I draw a line like this, we have lots of different angle relationships that we could figure out. So one thing that we can say is that this angle and this angle, those are congruent because they are corresponding angles. So I know that angle 1 also has to be 53, right? So that's one piece of information we could use. We also have a different transversal over here. If you look at this side, right? And I have another set of corresponding angles. This angle and this angle, those are corresponding. That means angle 4 has to be 59. And then we're kind of getting into an area now where we could do a lot of different things. So I'm going to clean up some of these markings here just so I can see what I have left. So I know angle 4 is 59. If you look at this, we have another straight line, right? Like this is a linear pair. These two angles make a linear pair. So I could do 180 minus 59, and that would give me the measure of angle 5. So if you subtract those, you're going to get 121. So the measure of angle 5 is 121. And the only angle that we're missing now is angle 3. That's the only one we need to find. And what I would do, some of you have probably already realized this, you have a triangle right here. Like I'm going to shade it in so you can see what I'm talking about. This right here, that's a triangle. And with triangles, remember, they always add up to 180. All the angles add up to 180. So you could take 53 and 59, and you could just subtract those from 180, right? You could add them together and then subtract them from 180. And once you do that, you are going to get 68. So that would be the measure of angle 3. And we've filled in all the angles. We just need to list them out over here now. So let's see, the measure of angle 1, we know that that's 53. So is angle 2, right? Angle 3, that's the one we just found. That one was 68. Angle 4 is 59. And again, I'm getting all these numbers from my picture over here because I labeled my picture. And then angle 5 was 121. And that's it. So this is kind of how I would recommend doing problems like this. I would just start filling in your picture instead of trying to find them in the order that they list them, because sometimes the order that they list them doesn't always make sense. I would just fill in the picture and then fill in all your answers afterward. Okay, so let's take a look at problem number 7. All these problems are very different. I wanted to give you a good variety of stuff that you might see. So if we look at number 7, this time they're telling us that these are all mid-segments. So all these segments in here, those are all mid-segments. And we're supposed to find the perimeter of JKL, which means we need to find the outside of this triangle. So this one requires a little bit of work. So let's see. We first need to figure out what X is, right? Because in order to find the perimeter, I kind of need to know what X is eventually. So let's see if we can make an equation. I know that this side is parallel to this mid segment. So remember, if I take 2 of these, that's going to be equal to the bigger side. So I want to do 2 times the mid segment, which is 6x minus 1, and set that equal to 13x minus 10. And then I'm just going to go ahead and quickly solve this. I know that we know how to solve equations like this already, so I'm not going to do this super slow. I'm just going to distribute 12x minus 2 equals 13x minus 10. And then once we move this over here, we're going to get just 1x. X minus 10 equals negative 2, and then we can add the 10. And we'll get x equals 8. Okay, so we've just solved for x. And now we need to plug it back in because we need to figure out what some of this stuff is equal to, right? So I can plug it back into this side to get the length of this side here. So 13 times 8 minus 10, that's gonna, when you plug all that in, that's gonna equal 94. Now the other sides, you can actually go ahead and get those right now. So we can use these mid segments here, so like 49. If I double that, that's going to be equal to this side that's across from it. So 49 times 2, that would give me 98. And then I only need one more side now. So if I take 42, that one is parallel to this side. So if I take 42 and I double that, 42 times 2 is 84. So that's my third side over there. And now I have all 3 sides. So they want the perimeter, which means I would just add up all 3 of those sides. So the perimeter of JKL would just be 84 plus 94 plus 98, which gives us 276. Okay, so that's how you do the perimeter problem. And then we have 2 more problems here, and these ones involve a little bit of algebra. So let's take a look at number 8. So number 8, it's asking us to find the measure of an angle, measure of angle CBF. CBF would be this corner angle right here. So if I knew what x was equal to, then we could figure that out, right? Now remember, we have parallel lines because that's a mid-segment, and we have a transversal here, which means these are corresponding angles. Those have to be congruent. So we're going to set these 2 angles equal to each other. So we can say 9x plus 2 equals 15x minus 52. And then we'll just go ahead and rearrange this and solve this equation. Once you move stuff around, you're going to end up with 6x on one side and 54 on the other, which means x is going to equal 9. And then to get the angle that they wanted, you would just take that and plug it back in. So 9 times 9 plus 2, that would give us 83. So 83 degrees, that would be the measure of angle CBF, 83 degrees. All right, and then last one on this page, number 9. This one also is dealing with angles, but they're a different pair of angles. So if you look at the mid segment and the line that it's parallel to, so here's our parallel lines, and then this would be our transversal that we're going to use. This time they're giving us these angles here. And I know it's been a long time since we talked about this, but these angles will actually not be congruent. Remember, in parallel lines and transversals, these are called same side interior. Same side interior, and they're not congruent. They actually equal 180. So that's something we learned a long time ago, but they will add up to 180. So instead of setting these equal to each other, we're going to add them together and make it equal 180. So we can say 6x plus 1 plus x plus 4 equals 180. And then we'll just go ahead and solve this. When we combine our like terms here, we're going to get 7x plus 5 equals 180. And then we can subtract. We get 7x equals 175. And then once you divide, you're going to get 25 for x. And let's see what they want us to find. They want the measure of angle RTV. RTV. If you trace that, that's actually this corner angle here in the bottom. So that one's really easy to plug in for, right? That would just be 25 plus 4, which is 29 degrees. So that would be the answer for number 9. All right, and the last thing we're going to learn how to do is how to deal with mid-segments in the coordinate plane. So we're just going to do a couple examples of this. Sometimes you will be asked to kind of prove that something is a mid-segment. And it's actually pretty simple if we use things that we already know about slope and distance and stuff like that. We've done stuff like this before. So if you look at what that example is asking, it says, in triangle JKL, show that the mid-segment MN is parallel to JL and that MM equals half of JL. So they're kind of asking us to prove basically that this is actually a mid-segment. And in order to show that information, we have to do two things. We have to first of all prove that these lines are actually parallel, and then we also have to make sure that this is equal to half the amount of this one, okay? So it's actually not bad. We're going to go ahead and do that. So first, we're going to use slopes, right? That's how you show that lines are parallel. So if I find the slope of this line and the slope of this line, they're supposed to be the same slope in order to be parallel. Now you can find slope a bunch of different ways. Some of you prefer to just do like rise over run. I'm finding that a lot of you are messing that up though, and I don't really know why, but a lot of you are not calculating slope correctly when you count rise over run. So if you want to, you can just use slope formula, right? Like you can write out your coordinates. So the coordinate of M would be, what is that? -4, +3. And the coordinate of N would be 0, 2. And we can just use those coordinates to find slope, right? So I'm going to go over here. Let's find the slope of MN first. And when you do slope, it's just y2 minus y1 over x2 minus x1. So let's do MN. That would be, I'm going to use this one as my x2, y2. So that would be 2 minus 3 over 0 minus -4, which would give us -1 on the top, +4 on the bottom, because you got this double negative going on here, which means our slope of MN is -1/4. That's the slope of MN. So I just did that with slope formula. Now I do want to mention, like I said before, you don't have to use slope formula if you know how to find slope just by counting. So if you look at the points here, this is going down 1/4. That's -1/4, right? So like if you know how to do that, you can do it that way. Sometimes you might not have a graph though, or maybe the graph might be really hard to read. So it is a good idea to use slope formula just to double check. So slope is -1/4. So let's find the slope of the other one. So we're going to find the slope of this line because those are supposed to be parallel. So, and they actually gave us the coordinates for those, right? So we can just use those two coordinates. So the slope of JL, let's see, it would be -1 minus 1 over 2 minus -6, which would give us -2 on the top. This is like 2 plus 6, right? Which is 8. And that does reduce to -1/4. So we've just shown that the lines are parallel. And that's all that we have to show, right? We just have to make sure that the slopes are exactly the same. And this right here, this is the work that I would need to see if you were doing this problem like on a test or something. I would need to see this work, or I would need to see you doing your work on your graph if you're finding slope from a graph. I would just need to see that you did the work. Okay, step 2. So what we've just done, we've done this part here where it said show that the mid-segment's parallel. That's what we've just done. Now they're asking us to show that this is true. So I want to show that the mid-segment is half of that bigger side. And to do that, we just use distance formula. So we're going to find the distance between those sides. So, or between those points. So let's take a look at our triangle here. So once again, I'm going to need the coordinates of the mid-segment. This one was 0, 2. This one was -4, +3. And you can do distance formula however you want. We've done it over and over and over again. So the big distance formula, if you're a formula person, it looks like this. x2 minus x1 squared plus y2 minus y1 squared. So that's the distance formula. Now, I've talked about this a million times, and you guys know that I don't typically use this formula. I find little shortcuts to help me figure it out. I do like the thing where I make a triangle out of this, and then I kind of do Pythagorean theorem. But you guys can do this however you want to. So I know that a lot of you like to use the whole formula, so I'm gonna go ahead and do it that way. So if you look at the coordinates, I'm going to start by finding the distance of MN. Let's start with that one, MN, which is the shorter one, the mid-segment. And I have the coordinates already listed up there, so let's just label them. We'll say this one's x1, y1, this one's x2, y2, and then we're just going to use a distance formula, right? So let's go ahead and do that. In the first set of parentheses would be my x values. So if I start with x2, that would be 0 minus -4 squared. And then if I put my y values in there, that would be 2 minus 3 squared. And let's go ahead and figure out the math here. So 0 minus -4, that would turn into 0 plus 4, right? Which would be +4. So this is 4 squared plus -1 squared, which would be the square root of 16 plus 1, which is the square root of 17. And if you put that in a calculator, the square root of 17 is approximately 4.1 if you round. Okay, so that's the distance of MN. And now we're going to do the same thing, except we're going to find the distance of JL. And we're going to try to see if that relationship holds true. So let's go ahead and do that. So same exact thing. We have the coordinates for JL. So that's what I'm going to use. This one will be our x1, y1. x2, y2, and then let's go ahead and figure it out. By the way, I always have people ask, like, does it matter which one you do, x2 or x1? It doesn't matter at all, right? So you could have started with this one if you wanted to. It doesn't matter, as long as you're consistent. Okay, so distance formula for JL, that would look like 2 minus -6 squared. Oops. Plus -1 minus 1 squared. Okay, and let's simplify a little bit. This would become +8 squared plus -2 squared, which would give us 64 plus 4, which is the square root of 68. And if you go ahead and put that into your calculator, the square root of 68 is approximately 8.2. And you can see that that relationship is true, right? If you take 4.1 and you double it, 2 times 4.1 equals 8.2. So this works out. Everything is exactly what we thought it would be, right? So they said show that MN equals half of JL. We've just shown that that's true. 4.1 is half of 8.2. So that's all set. That's how you do this. So, and I know that it's a lot of work. Remember, you don't always have to do all of this work. There are shorter ways to do distance formula. I've talked about them many times. You guys can use the little right triangle thing with Pythagorean theorem. You can take shortcuts when you do your subtraction stuff here. So just find a way that works for you. But that's all we're doing here. We're just finding slopes to show that the slopes are the same. And then you're finding the distances to show that this is half of the bigger distance. So there's one at the bottom there that you guys can try on your own. If you want, you can go ahead and have the sub pause this video if you would like to try it on your own. Or I will just keep going. And you can just kind of follow along at your own pace. So if you want to try it on your own, just pause the video here. If not, then I'm just going to continue. Okay, so we're going to do the same thing here. We're going to show that ED is parallel to BC, and we're also going to show that relationship between the distances, right? So let's start with the slopes. So that's the first thing we're going to do here because we want to show that they're parallel. So I'm going to find the slope of ED first. So slope of ED. So if I look at my coordinates here, now I know that they didn't list out the coordinates this time, but you guys could write them out if you want to, right? The coordinates of E would be +1, +4, it looks like. And then D is at +2, +1. So those are the coordinates of ED. Let's go ahead and find the slope really quick. Slope shouldn't take very long. At this point, you guys should kind of know how to do slope. So I'm going to go ahead and do my y2 minus y1 over x2 minus x1. All right, so I would have 1 minus 4 over 2 minus 1, which is -3 over 1, which is really just -3. All right, that's the slope of ED. And then we'll find the other slope. So the slope of, so we want to do the slope of the segment that's supposed to be parallel to it, which would be BC. So let's list out those coordinates. B is at +3, +4, and C is at, what is that, 3, 4, 5, -2. Okay, so let's go ahead and find the slope. So that would be -2 minus 4 over 5 minus 3, which would give us -6 on the top, +2 on the bottom, and when you divide that, that is -3. So we've just shown that the lines are parallel. All right, now let's do the second part of this problem. We're going to show that the distances are half, like the smaller one is supposed to be half of the bigger one, right? So let's go ahead and do that. We're going to find the distance, or I guess I'm going to call it the length of ED. So length of ED. I already have my coordinates listed right up here, so I'm just going to use those. And let's go ahead and fill in our distance formula. So we start with the x's. And remember, it doesn't matter what order you subtract. It doesn't matter at all. Like you could go 1 minus 2 or 2 minus 1. It doesn't matter because we end up squaring these numbers anyway. So it doesn't matter what order you subtract them. I typically start with the second one minus the first one just to be consistent, but it really doesn't matter. So I'm going to go 2 minus 1, and then we'll do the y values. So that would be, I'm going to go 1 minus 4. And then let's simplify, right? 2 minus 1 is 1, so this would be 1 squared plus -3 squared, which would give us the square root of 1 plus 9, which is the square root of 10. And then you guys could go ahead and figure out what that is as a decimal. The square root of 10 is approximately, I'm going to say, it's 3.16. We can bump it up to 3.2 if you want to, or you can call it 3.16. I don't really care how you round here. That's the length of ED. Now let's find the length of BC. And once again, I have my points listed up here, so I'm just going to use those points for my distance formula. So let's start with the x's. I'm going to go 5 minus 3 squared plus, let's do the y's now, -2 minus 4 squared. And then let's just simplify here. This would be 2 squared plus -6 squared, which is the square root of 4 plus 36, which is the square root of 40. And then let's figure out what that is approximately equal to. Okay, so it looks like it is about equal to 6.32. I'm going to keep 2 decimal places because you can see, if you keep 2 decimal places, you can see how 6.32 is twice as much as 3.16, right? We've just shown, that ED is half of BC. And that's because 3.16 is half of 6.2, right? Okay, so that's it. I know these take a lot of work to show, but this is how you would do it. You're just finding slopes and finding distances, right? Okay, so at this time, what you guys are going to work on now is the practice page. There's a single sheet, front and back, about 6.4. It's called 6.4 practice. It's not a homework thing. It's something you're going to do in class, okay? This is something you should finish in class. And then when you're done with that, you can get the study guide for the chapter 6 test, and you guys can start working on the study guide. Okay, so that's what you're going to work on. Start with the 6.4 practice, and then you can get the study guide when you're all done with that. And just email me if you guys have any questions. Bye.